Welcome to iLecture Online, and here we're going to talk about the slope, concavity, the maximum, minimum, and inflection points of a function. And for that, we're going to use derivatives, the first derivative, second derivative. We're going to find the slope, we're going to find inflection points. And before we get all started on that, let's make sure we understand what those things are. So what I've done is I've put on the corner there a little graphic we can reference later. But I want to go over that very same curve. This is the same curve, a little blown up here. And I want to indicate to you what all these various things are. So first of all, slope. The slope is the steepness of a function at particular places. You can see that from here to there, the slope is positive because it rises as you go to the right. So here we have a positive slope. Over here from there to there, we have a negative slope. From there to there, we have a positive slope. And then from there to there, we still have a positive slope. So slope is simply the derivative of a function. And here you can see that the slope is positive. There's negative, positive, and positive. All right, concavity. Concavity is how the slope changes. You can see that from there to there, the slope goes from positive to negative. So the slope goes from a large slope to a small slope to a negative slope. So they call this concave down. So this is considered what we call concave down. And then here, in this region right here, we go from negative slope back to a positive slope. So the slope increases there. So they consider this region here on the curve to be concave up. And then over here, the slope is changing from there to there. So we could say that this is concave down. And then over here, we consider that this back is concave up. So the concavity of a curve simply explains how the slope is changing. Is it becoming smaller, concave down? Is it become bigger, concave up? Smaller, concave down, bigger, concave up. Then we also have points on the slope, points on the graph where the slope is 0. So when we top out here at the very top, you can see that the slope is 0. And if the slope is positive here and negative there, that's a maximum point on this curve in this particular locality. So this is considered a maximum or a local maximum point on the graph. Over here you can see that it bottoms out. The slope over here is 0, and so this is considered a minimum point on the graph. And then if you look over here, you can see that the slope here is 0 again, but in this case it's not a maximum or minimum. Even though it gets bigger, then it levels off, and then it continues to get bigger. This is not considered either a maximum or a minimum. This is what we call an inflection point. So where the slope is decreasing and then the slope becomes increasing again, we call this an inflection point. And if you look at another place here, again, here we have a region where it's concave down, and here there is a region where it's concave up. Where this changes, right in the middle here, that is also called an inflection point. There's one fundamental difference between these two inflection points. This inflection point right here, there's no max or min value, meaning the slope doesn't go to 0. Over here, the slope does go to 0, so make sure there's a very big difference. You see the difference between those two inflection points. If we're trying to find the point on the graph where the slope is 0, we'll find the point over here, we'll find the point over there, and we'll find the point over there. This point will not be found by finding the places on the curve where the slope is 0. Which means that when you find a place on the curve where the slope is 0, you're not sure if you found an inflection point or a max or a min. So you'll have to do some additional tests to figure that out. If you find an inflection point, you're not sure if you find this type of inflection point or this type of inflection point. So again, you need to do further tests to figure out which inflection point you're dealing with. So this at least gives you a pretty good feel of what we're trying to do when we try to evaluate a curve, when we're looking for maximum points, minimum points, inflection points. This is what I would call a horizontal inflection point. This is a non-horizontal. I tend to call them vertical inflection points, even though they're not exactly vertical, but they're not horizontal. We also need to figure out how to find where the slope is positive, where the slope is negative. We also need to find out where the curves are concave down and where the curves are concave up. So concave up, concave down. Maybe I'll draw a little arrow here. Here you can see that this part of the curve it's concave up. Which means if this is concave up and this is concave down, there must be one more inflection point right there. So this is another inflection point, and again, it's not the horizontal type, it's what I would call the near vertical type. So here's another inflection point. So you can see that inflection points are found everywhere where the curve goes from concave down to concave up, or from concave up to concave down. But not all of them are vertical and not all of them are horizontal. You'll have to figure out which way they are. All right, so this gives you a little introduction. Let's now do some nice examples where we can apply the techniques to find all these various points on a graph.